Hey there, class. Mr. Pawhuski here. Hope you're having a good day so far. We are continuing with Chapter 3, which is Systems. We are doing 3.3 today. The name of this lesson is Systems of Inequalities. Our essential questions are: be able to determine if an ordered pair is a solution to a system of inequalities, be able to graph a system of inequalities, and be able to determine the solution to a graph of linear inequalities. So, graph paper is a very good idea for this lesson, okay? So, if you're able to go to the store and get a notebook that has graph paper in it, that would be awesome because it's going to make your life very easy, much easier than it would if you didn't. Yeah, it's going to be very hard to do this assignment without that, okay? So, we are graphing systems of inequalities, which is the moral of this story. Systems of equations is where they cross. Systems of inequalities, we have dashed and solid lines, and we also the solutions are going to be where the regions that they represent overlap. Okay, so we're going to review how we graph like regular inequalities and stuff, and then we're going to see where they overlap. That's going to be the solution to these. This is kind of a review from Algebra 1. Okay, example 1 says determine if 5, 9 is a solution to the system of inequalities. So if it's a solution, it should be true for all inequalities. So we're going to plug this in for x and y. Why don't you guys go ahead and pause the video, see if you can do that real quick. All right, we're plugging in for x is greater than or equal to 2. So x is 5. So we're going to do 5 is greater than or equal to 2. Is that true or not? That is true, so it's good for that equation. Let's check the second equation, though. 2 times x, which is 5, plus y, which is negative 9, so minus 9 is less than 4. That's not good for. Well, it's still not good for, but whatever. All right, let's simplify this now. 2 times 5 is 10. Minus 9 is less than 4. What's 10 minus 9? It is 1. Is 1 less than 4 or not? It is. This is going to be a solution because it satisfies both equations. That's an easy one to start with. It's going to get harder from here. This is a hard lesson, so just pay close attention. Ask questions, during class. Let me know how you're doing, but it is kind of a tough lesson for today, okay? Also, people, if you pick up the materials pickup, you'll be able to grab some graph paper, which I'm passing out, okay? All right, sounds good. So example 2, it says graph to determine the solutions of the following systems. All right, well, to graph lines, we need to have it in y equals mx plus b form. That's going to be the easiest way to do that. And so what I would probably do first, we have x minus 2y is less than or equal to 3, and y is greater than 3x minus 4. So this one's good, but we need to get the top equation, make that equal to y. So we're going to go ahead and do that. So we have x minus 2y is less than or equal to 3. Now we need to solve for y, get y by itself. How do we do that? What's the first step? We need to subtract x. We get negative 2y is less than or equal to negative x plus 3. Put the x in front when you're solving this because it's y equals mx plus b. Last step to solve for y is to divide by negative 2. Divide by negative 2. Sorry, I got distracted. So one thing we need to be careful about, though, and there's a lot that can go wrong with these problems here, guys. There's a lot of moving parts here, okay? So just, even if your regions don't work out perfectly, that's still okay, but still follow the process here, okay? We divide by negative 2, so we need to flip the inequality from less than or equal to greater than or equal to. And then negative x over negative 2 is 1/2 x. Put the slope in front, makes it easier to see. And then we got minus 3 over 2. 3 over 2 doesn't divide nicely. So our two equations are y is greater than or equal to 1/2 x minus 3 over 2. And the other equation is y is greater than 3x minus 4. Okay? A couple things I like to do when I'm solving these, though. I'm going to do this. I'm going to draw a little arrow here. So is this a solid or a dashed line if it's just greater than? Okay, so for a refresher course, let's talk about that here. So y is less than or y is greater than, that's a dashed line. And then y is less than or equal to, y is greater than or equal to is a solid line. And then if we have y is less than or y is less than or equal to, that's below. And y is greater than or y is greater than or equal to is above. So we have two things happening here, okay? So when we're doing some shading, and we're also figuring out what kind of line we're going to have here. If it's not equal to, that means that line is not part of the solution, which means that we need to do some, like a solid or a dashed line, and also shade above or below. So if we have y is greater, then that's going to be a dashed line. That's going to be shaded above. All right. Then the bottom equation is going to be, that's going to be a solid line because it's equal to. It's going to be shaded above. So let's graph this now. So we have y is greater than or equal to 1/2 x minus 3/2. We graph the line like it would be y is equal to 1/2 x minus 3/2. So we are solving this, we graph the y-intercept first, which is negative 3/2, which is negative 1.5. So we're going to go down 1.5, put a point. And then our slope is 1/2 x. We're going to go up 1 over 2. Up 1 over 2 is still going to be in the half spot here. Up 1 over 2. Up 1 over 2. Up 1 over 2. And then we can also go the opposite direction, which I would encourage you to do. Go down 1, left 2, the exact opposite direction. It's a solid line, so we're going to go like this. We're just going to draw a solid line like this. And we're shading above, so I'm going to use red for the shading. I'm just going to draw a couple arrows. I'm not going to shade right away because it's actually where they overlap. I'm just going to draw a couple of arrows to show, kind of which direction we're going to kind of go. All right, then we got the green one. So it's a y is greater than 3x minus 4, so we're going to graph the line y equals 3x minus 4. So equals 3x minus 4, we're going to start at negative 4. Down 1, 2, 3, 4. And then we're going to go, which direction? Our slope is 3 over 1, so we're going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. We can also go the exact opposite direction, which is down 3 left 1, and down 3 left 1. So this is a dashed line, though, so I got to use a dashed line here. So I'm going to connect all these dots with a dashed line. And then we're going to do some more shading with the red. Okay, but now so it's above the green line, so we're going to go above. I'm not going to draw an arrow down here because we know it's not down there already because it needs to be the same. It needs to match what the previous line said, which was up here somewhere. So we're not going to shade down there. So we're going to go above, above, and above. So we're going to shade right over here. This is our shading right here. It's this area. This is where they overlap. And that's going to be all the solutions. Okay? So that's kind of how you do these problems. You graph them like they would be. I should draw them closer to the line here. All right, so that is how you do this. The solution occurs where the shaded regions overlap. Okay, so some people like to draw they like to draw the shading for all the different things. That gets kind of cluttered when you draw the shading in all the way because you're using pencil. So I like to draw arrows to know where to go, and then it makes it easier to see. All right, we got 3 more examples here. So these are going to take a little while. Just be patient, follow along, and you'll be doing just fine. All right, so we have x is greater than or equal to 0. So first of all, that's going to be a solid or a dashed line. That is solid. And it's shaded to the left or to the right. This is x is equal to 0 would be a vertical line through 0. Remember Hoy-Bucks? We got to remember Hoy-Bucks. This is going to be solid and shaded to the right. And because it's a vertical line, we're either going to shade to the right or to the left. And so if we have x is less than, that's shaded to the left. And if it's x is greater than, it's going to be shaded to the right. Okay, so just keep that in mind with Hoy-Bucks. All right. So that is what we have we have solid and shade to the right. So we have x is equal to 0. We graph that line. That's a vertical line in Bucks. The vertical line x equals 0. So I'm going to draw a vertical line through x equals 0. Kind of hard to see, but we're shaded to the right. So I'm going to draw some arrows going to the right a little bit just to give us some sense of where to go. Okay. Next, we have y is greater than or equal to 1. That is going to be a solid line because it's equal to. And shaded to it's going to be above or below if it's greater than with y. It's going to be shaded above. Okay, above. If it's greater than, it's shaded above. If it's less than, it's shaded below. So we're going to do a horizontal, y equals 1 to be a horizontal line through y equals 1. So we're going to do a horizontal line through y equals 1. And we're going to be shading above. So now we know it's already over. We already know it's over in this direction, so we're not going to put arrows over there. We're going to put arrows up here. Well, it's not. Let's use red, actually. We know it's going to be in this overlapping area over here. Okay, and the last equation we have to solve for, we have to get y by itself. So how do we get y by itself here? We need to subtract 2x. We get y is less than negative 2x plus 4. Okay, is that going to be a solid or a dashed line? It's not equal to, so it's dashed. And it's shaded above or below. It's below. It's less than. So we're going to graph this line. We got y is less than, so y is equal to negative 2x plus 4. We're going to go up 4, 1, 2, 3, 4. Then we're going to go down 2 over 1 as our slope. Down 2 over 1. We're going to go up 2 left 1. And now we're going to use a dashed line because it's not equal to. All right, we said shaded below. So we gotta go to the right of the green line, above the pink line, and below the blue line. So that's gonna be down here. Let's use a solid line. So that's gonna be this little triangle here that's shaded in. That's above to the right of the green line, above the pink line, and below the blue line. That's our solution right there, where they all overlap. All right, 2 more examples here. The next example is a little bit not as tricky, but then the last example is pretty involved. So let's stick with it here. Let's use green to start. Okay, so we have x is greater than negative 2. Is that solid or dashed if it's greater than? It's dashed because it's not equal to. It's a left or right if it's greater than. It's going to be shaded to the right. X is greater than is to the right. X is less than is to the left. And then let's go ahead and graph that. So we have dash line, but we're going to do a vertical line through x equals negative 2 because it's a vux. In Hoy Vux, it's a vertical line. So we're doing a vertical line through x equals 2. We're shading to the right. Let's draw some arrows to the right a little bit. Just kind of all the way along the line. Then we have x is less than 3. That's a dashed line again because it's not equal to. And it's going to be shaded to the left. So we're going to do a vertical line through x equals 3. 1, 2, 3 is over here. I'm going to put the dots there. Here's a vertical line through x equals 3. And then we're shading to the left. So drawing to the left. You can see they overlap right here in the middle. And there's our solution. All right, last example is kind of long, and it's going to take a little while, but stick with me, and we'll be done for the day. All right, so first thing we have is y is greater than or equal to negative 3. Is that a solid or a dashed line if it's equal to? It's a solid line, and is it above or below if it's greater than? It's above. Let's do so it's a Hoy, y equals, in Hoy Vux, is a horizontal line. Let me just talk about Hoy Vux really quick here, just in case. I don't know, I didn't mention it earlier. We talked about it a lot, but it is important. So a horizontal line, these are 2 separate things here. Horizontal, 0 equals the slope. Y equals the numbers, what the equation looks like. And across, yeah, we're going to put y equals a number. It's a vertical line, undefined slope. And it's going to be x equals the numbers, what the equation is going to look like, okay? So yeah, and some people say crosses y-axis helps them, I guess. I don't really see that, but x-axis. Okay, so if you see y equals a number, boom, it's automatically a horizontal line through that number. If you see x equals number, boom, it's automatically a vertical line through that number, okay? Sorry I didn't talk about that sooner, but I kind of took it for granted that we know how to do that at this point, so. But I shouldn't take things for granted. That's not a good way to live. All right, so we have y is greater than or equal to negative 3. That's a horizontal line in Hoy. Horizontal line through negative 3. That's a really bad line. Horizontal line, it's solid, so we're going to shade above. So we're going to use trust little arrows here. Okay, to get us started. Then we have x is greater than -2. That's a dashed line. I'm just going to kind of go together here. And it's going to be shaded to the right because it's a x equals is a vertical line. So we're doing a dashed line through -2. And we're going to shade to the right. We're not going to shade, we're going to draw little arrows to the right. We're going to stop where they overlap. We're not going to continue down here because we already know it's above the green line, right? Okay, next one, blue. Next one we have y is greater than 3x minus 1. That's going to be dashed. And once you get to the point, you can just kind of do it. You don't need to write this out every time, but I'm just making sure we see how this is working here, all right? Dash and above. And there's a motorcycle outside, they're super cool. All right, so we have y is greater than, so y equals 3x minus 1. We're going to go down to -1. Put a point, we're going to go up 3 over 1. Up 3 over 1. Up 3 over 1. And then we also go down 3 left 1. Down 3 left 1. Down 3 left 1. That's a dashed line, so we've got to do a dashed line now. And it's shaded above, so we gotta draw some arrows above the blue line now. Above the green and the blue. It's gonna be up here somewhere. Oops, those are not what I want. So we're gonna go above. Somewhere in that little triangle at the top there is where we're gonna be. And the last one, what color? Let's use purple. Now we gotta solve for y here. Let's subtract x from both sides. 3y is less than or equal to -x plus 12. Divide by 3 to get y by itself. Y is less than or equal to -1/3 x plus 4. So we're going to go which direction? What's the first? And this is going to be solid and below. So we're going to start at +4, go up 4, 1, 2, 3, 4. We're going to go down 1 over 3, down 1 over 3, down 1 over 3, up 1 left 3, same exact opposite direction. And it's a solid line, so we can do a solid line now. Might be good to use different pen colors here. And then now it's below, so we got to be above, to the right of the green, the pink line, above the green line, above the blue line, and below. That's actually not what I wanted. We want below the purple line. So you can see it's all going to be in this area right here. I'll shade this all in. You can see it's just this shape right here. Now I get to just shade it in like we're coloring. And if you were to shade in the whole graph as you went, you would have a really convoluted looking graph. But now we know exactly where the solution is for this. Okay. All right. Thank you for watching. Have a great day, and we'll talk soon.